Hi, my name is Allison Beonde, and I want to talk to you about mimicry and defense mechanisms in common Louisiana moths. So the first one I want to talk about is the flannel moth, otherwise known as a puss caterpillar or asps. You can see on the left there, this is a picture of one of the late instar stages. They have these hollow spines that are attached to venom glands that are hidden underneath these soft setae when they're in these later instar stages. So they often look really fuzzy and really soft, but they're hiding these venomous barbs. In the middle, at the top there, is one of the cocoons. On the bottom is a picture of an adult male. On the top right-hand side, I think this is really cool. They actually form their cocoons by using their larval hairs. They'll actually sort of shed them off as they're building their cocoon and push them out through this little pocket to sort of mat down and make the exterior of the cocoon. The bottom right, you can see this is another really interesting thing they do. They have a pre-adult that emerges and exposes this pupal exoskeleton, and they will then break out of that. So they have this pre-adult that comes out of the cocoon, and they break away from that to leave as an adult, and they leave behind this exuvie. The next one is an Io moth, otherwise known as a corn emperor moth, really commonly for being found in cornfields. At the left, you can see one of the fifth instar stages. So all of the instars have both point and setae-bearing barbs. And the fifth instar has this red and white line down the side, sort of warning of its irritating qualities. The center image here of an adult male, and you can tell the males apart for having this really bright yellow coloration. The females often have this reddish-brown hue, which is denoted by the extra prefix of Lilith. So in the top right, you can see a version of the female there. And on the right side, I wanted to put this nice comparison with an eastern screech owl. The adult moths have these really wonderful adaptive eye spots that have this reflective mimicry. They actually adapted to have this white area inside of the black circle to appear like larger vertebrate eyes that are catching the light and reflecting it back. And my third one here, the salt marsh moth, another really interesting one. It's in the tiger moth family. On the left-hand side, this is one of the sort of middle instar stages, getting towards late instar stages. But the larvae will seek out and consume plants that are high in pyrrolizidine alkaloids, or PAs, and they'll actually use those chemical qualities to repel predators. And in their adult stage, they'll actually synthesize them into their courtship and mating hormones. In the center, you can see the adult female at the top and the male at the bottom. You'll notice the females have white hind wings with these sort of peppered spots, and the males have these more golden colored hind wings to them. On the bottom right, you can see one at night feeding on a flower, doing its pollinator duties. And they have actually adapted to click to make these sounds, often with something called a timbal on their thorax, to alert bats that they won't taste good, that they're kind of noxious and they don't want to be eaten. In the same family is another moth, Bertholdia trigona, still in the same related family. That is the first one ever to be thought to actually jam bat sonars. So bats, when they're hunting, will send out about 200 clicks per second as they're approaching, and this one will send back 4,500 clicks to sort of baffle that sound. So I think these moths are really cool. They've adapted some really interesting mechanisms to avoid predation and to continue evolving and maintaining as a species. And I'm so excited to share these with you today. And here are some of my resources and references that I used and photographs included throughout the presentation. Thank you.